Okay, so I've done a little bit of prep. We've got a CSS file with some cleanup and a basic sort of structure for the body and some colors and general positions for the game container itself. In the HTML, we've got our standard sort of style sheet and script links. We've got a simple container class, and then we've got this actual canvas here. I've just made it like 640 by 480 to give it that sort of retro feel like television. Then in the JavaScript, what we're doing here is we're grabbing the game canvas, we're getting a 2D context to the canvas, we're setting the X and Y coordinates to something. I think DX and DY can be set to 0 for now. So all I've done is I've got the canvas width divided by 2 minus 10. Now 10 is half the width of the actual rectangle that I'm drawing and half the height. So it's basically just putting it in the middle of the screen, theoretically. So X and Y just get the height to the middle of the screen. I've got this function called drawBall. All it does is it sets fill style to green. So it's going to be background. It's going to have a color of green. Draw a filled rectangle at X and Y of size width 20 and height 20. So it's basically just drawing this little sort of square of green. Then we have a render function that does nothing just yet. This is going to do all the drawing. Then we have an update function here, which is going to do all like the general logic of like movement and whatever else. We have this game loop, so function game loop. It calls update, then it calls render, then it requests the next frame. So it basically loops. So it's kind of like game loop. We then run the game loop, so it's just constantly running. Now, our thing at the moment with this working looks like if I refresh the page, that's it. It's just got this general canvas here. I've grayed out the background here. I've got a darker gray as the background for the canvas, and I've gave it a nice 2-pixel white outline, so you can kind of see where the canvas is. At this point, we want to kind of render some ball to the screen. So we can we could draw the ball, couldn't we? Let's save that. Now let's take a look. We refresh the page, we have a ball. Now, there's something wrong with this rendering, and I'll kind of show that by let's do some updates. Let's say our X position plus. So every single time we render a frame, it's going to move 1 pixel to the right. So press that. Now, if I refresh this page, notice how it's kind of just drawing a line. So I have a slight problem. It's moving the object, but it's not removing the tail of the object. It's not clearing the screen. Funnily enough, we have a clear screen function. So what we do is before any drawing happens, we do a clear screen. Now, if I refresh this page here, it does the animation. Like it's moving to the right. If I did like X minus minus instead, I refresh the page, it's moving to the left. If I do a Y minus minus and refresh the page, it goes up the page. If I do a Y plus plus and refresh the page, it moves down. So in essence, we can kind of move in an up, down, left, right manner. Or if we wanted to move both down and to the right, we could do X plus plus as well as Y plus plus. So when we refresh the page, it moves down to the right and so on. So we can kind of decide on a direction. So what we could do is we could say, okay, well, at this point, I just want X to move in the DX direction X, yeah? Y to move in the direction Y. At this point, they're both 0, so it should literally just stay still. If I change DX to something else, so where's DX? So we'll change DX from 0 to 1 and save it. If I refresh, it's going to start moving in the DX or direction X. So we can kind of change these based upon what we want it to do. In which case, we could give it like an initial thing of, let's say, 2. So 2 pixels and 2 pixels. Let's save that. Let's refresh the page again. I'm saying it's might feel a bit jumpy actually. I don't know. Is that okay? It's not brilliant. It's okay for now. We can play about with decisions on how fast you want it to move. But in general, that means that we now have that. Now, what we could do is we could check for collision with the bottom. So let's try that. Let's try a collision detection. Let's say, okay, if so what we got? We've got X. Yeah. Now X is going to be technically the top left corner of our rectangle. So that means we need X plus this number here, 20. And that'll be the bottom of our rectangle, right? So if X plus 20 becomes greater than the canvas dot height, yeah? Hang on a minute. No, X is going to be right, isn't it? So width, canvas width. So if it gets greater than canvas width, we'll say X equals canvas dot width minus 20. Yeah. So theoretically that does that. Just for now, just keeping it in the bounds. So if I save that and I refresh, it doesn't work. Why is that? What's the thing that happens here? What's the problem? Well, it may work. We don't know because it's gone off the down part of the screen first. So we can't see it when it actually hits the right side. It may have stopped and just carried on going down. So now what we can do is we can say, well, let's say the same for the Y. So let's copy this, paste it here. And this time we want to deal with the height. Same here. And instead of X, we want that to be Y. Now if we refresh it, it carries on, go dunk. So it can only ever get to that corner there at the worst. Notice how it stopped when it hit. If I refresh this again, bang, still carries on the X until it hits that. So we've now kept it so it can't go any further, right? That's great for keeping it within bounds. But we know that that's the bounds. So what could we do here? We could maybe just change dx instead. Maybe we could just reverse it. So we could say dx equals negative dx. And same with dy. Could say something like dy equals negative dy. So just reverse whatever it's got. So if I refresh this now, boing, boing, and it carries on. So we haven't dealt with the top and left. All we've done is we've dealt with the bottom and right. So it bounces off the bottom and bounces off the right at any given time. Now we want a similar sort of concept for the top and the left. So we can do that by saying if y, because that's the top left corner of it, well, x first, is less than 0, yeah, then dx equals negative dx. Right, so we've got virtually the same thing happening. Same thing with y. So, but before we do that, let's save that and let's refresh this. Boing, boing. And we can't really tell with the x because it's like, you can't. But we don't know whether it's changed direction or what. But we can do the same now with the y. So let's copy paste the y, and y. So let's save that. Refresh the page again. Bounce, 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 bounce. Seems to be working all right, right? How cool is that? Now, we could kind of consolidate a little bit of this. We could say maybe this thing here, yeah? And then maybe or this thing here. So now we've kind of dealt with both this one and the other one. So if we get rid of that, save this and refresh, that's bouncing, that's bouncing, that's bouncing, and that's bouncing. So nothing's changed other than the amount of code we just wrote. So again, another one here. Let's take that, put it here, or so two different conditions, because it's going to do exactly the same in both of those condition situations. We may as well just kind of consolidate. Let's save that. Let's do a refresh. Make sure it's still doing exactly what we wanted. We've now got like a bouncing ball program of some sort where it just kind of bounces. Now, it doesn't have to be this single rectangle. It could be whatever. The only downside is if we make this bigger, let's say 200 by 200, we change the code here and save this and refresh, it kind of doesn't bounce until it gets kind of right to there. So that doesn't quite look right, does it? That means we've got to change it here, kind of in multiple places. So it would kind of make sense to maybe, let's separate these onto separate lines so we can kind of see them easier as well first. And then we'll say ball size. Okay, so now ball size, we can go and change that to ball size. Change that to ball size. And then also change this size and, funny enough, ball size. Save that. Refresh the page. And now it's just utilizing that ball size variable. So if I change the ball size variable to, I don't know, 50, let's say 60, just to that. Now if I refresh, it will actually do the bouncing correctly as well. It doesn't, you know, we can change the size of it without it kind of messing up our collision logic as such. I'm going to change that back to 20 though, for a sort of a sane sized ball for our purposes. Let's see. So we could play about with the speeds here. Maybe, I don't know, let's try 3 to speed it up a bit and see what it looks like. Refresh that. Boing, 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 boing. There we go. So we kind of get this bouncing around thing going on there. Okay, so I think that's enough for one sort of session, and we can build upon this more and more as we go. A couple of extras we used fill rect this time, instead of actually just doing a put pixel in a sense. We used fill rect to make put pixel in the past, but I'm just utilizing it to draw an actual rectangle at this point. Okay, I'll see you in the next one.